Um, quick review that we got from life yesterday, all the way to the Paleozoic by adding photosynthesis, which caused oxygen to be around and have various effects. Eukaryotic cells show up a couple billion years ago, and then the last two things to get to sort of life as we know it was sex and multicellularity. The only other thing we have left is this particular pattern in the history of the Earth that we don't like to think about too much because it's scary. But the pattern is this: every once in a while, the Earth kind of shakes the old Etch-a-Sketch and gets rid of most of the living things on it. Various things happen to cause this, but we call them mass extinctions. And there's been about five. About five events in the Earth's history that killed a high enough percentage of all the species on Earth to be considered a mass extinction. The first we already talked about. The first was as a result of the oxygen being there, right? Photosynthetic cells put that oxygen in the ocean, and it killed most of the cells that lived. Other mass extinctions happened for other reasons. You probably already know about the ones where asteroids smacked into the planet. You'll learn a lot more about that, the particular one that wiped out the dinosaurs, when you listen to the podcast that you're about to be assigned. Volcanic activity can do it. We have these things on this planet called supervolcanoes. Basically, they look like big pimples on the Earth's surface, and there's several of them around the planet. And when one goes off, they all tend to go off, and that's something that can wipe out a lot of life. Climate change can cause it. Various things, but they happen, and they happen periodically. When's the next one? We don't know. Although enough species have gone extinct because of human activity that they're starting to call this period right now another, sort of the sixth mass extinction. Yeah.
Technically, we have the next one in a year.
One way to look at it, I suppose. How much time? Hard to say. Big sky. So obviously that's a bummer when that happens for the species that go extinct. Big bummer. But then there's the ones that don't. The survivors. It gets real interesting for them. Because if you're still alive and most of the species around you aren't, suddenly you have a lot more room to move. Suddenly there's a bunch of empty niches that weren't empty before, that maybe you were competitively excluded from, but not anymore. So it turns out what happens typically after a mass extinction is that the last species left standing, the ones that make it through the mass extinction, do this thing called adaptive radiation. And it's radiation not like space rays or nuclear fallout. We're talking about radiating out from a central point, like the radius of a circle. The idea that a species who suddenly has a bunch of open niches around it, the members of that population can radiate out into those new niches. And it tends to speed up evolution. Because, of course, natural selection is driven by the environment. If suddenly all these members of the population are in different environments, things start to change fast. It's the realization that this is how things work that led to one of the major adjustments in Darwin's theories, an adjustment that happened in the 80s. Because Darwin's thing was, hey, evolution happens slow and it happens at a steady rate pretty much all the time. His idea was called gradualism. But gradualism does not match the fossil record. And that became more and more apparent in the 70s and 80s that we don't see slow and steady change in the fossil record. We see slow and steady change for certain periods, sometimes long periods. But then every once in a while, it's like somebody hit the fast forward button and we see all these new species show up. Not just in the Cambrian explosion, but like 4 times after that. There's these gaps, there's these periods where suddenly everything jumps forward. And that was hard to explain until a couple of scientists named Stephen Jay Gould and Niles Eldredge started to work on the principle of adaptive radiation and came up with a theory that's widely accepted now called punctuated equilibrium.
Can you go back to the last?
Mm-hmm. Allie.
Does it make sense to say that like those gaps are just because like we don't have like the fossil organism, or is there like a bigger reason?
Yeah, so at first that's what we thought, is that not everybody's lucky enough to be a fossil, right? And skip some stuff. There are periods where it's not just that it's a gap, it's that like literally like suddenly a bunch of new stuff shows up. You know, which was weird until they timed those gaps, and it turns out that those gaps coincide with the periods after the biggest mass extinctions in history. Yeah, good question. So basically, this is saying no, it's not gradualism. It doesn't agree with the data we have from fossils. What it is that there's long periods of what Darwin said between mass extinctions, but and we see species that have lived in protected places for so long that they haven't changed much in hundreds of millions of years. The horseshoe crab, the cockroach, those species have been in a state of equilibrium for quite some time. But we also see post-mass extinction the evidence that adaptive radiation has very much sped up evolution, and that's when most new species get formed. Questions? Obviously, it's hard to know what it was like during those mass extinctions. But some really interesting work has been done recently on one of them, the one that ended the dinosaurs, which I learned when I was in school was a thing where asteroid hits and a bunch of ash and debris is thrown up and blocks out the sun for years, and all the plants die, and that's why there was this mass extinction. Well, recent data contradicts that. Recent data suggests something a little more spectacular. And so you're going to listen to a podcast. It's the same kind, just the same show, Radiolab, my favorite science podcast. It's called Dino Apocalypse, and talks about and interviews some of the scientists involved in kind of reconstructing what that extinction actually looked like. This is not something where you have a worksheet. It's not an ed puzzle. You're on your own. But just know that you need to have it listened to, you know, with your attention on it by Tuesday. And that Tuesday there is going to be some kind of, or Tuesday or later, there's going to be some kind of assessment over the big ideas in that podcast. Might be part of a larger quiz, or it might just be its own little form or something like that. But you need to be responsible for that information by Tuesday. Okay? It should be in classroom. Yeah, let's make sure it is. I don't trust myself.